June the 30th, Sun. Today is the second day since I arrived in Singapore. As planned, I set out to SusTech, Singapore's pioneer energy-efficient district, to investigate investment opportunities here. My first station is the Ocean Thermal Energy Conversion Platform on the open sea. The chief director here, Mr. Aquaman, shows me around. He explains to me that, moving towards a sustainable future, Singapore harnesses its 4 energy switches to meet the island's daily energy demands, which include natural gas, solar, regional power grids, and emerging low-carbon alternatives. Among the 4 switches, natural gas generates about 95% of electricity. However, as energy demand continues to rise, more sustainable, more efficient, and more financially feasible sources of energy are needed. SusTech derives 10% of its energy need from regional power grids, 10% from natural gas, 40% from solar, and 40% from the OTEC platform. The OTEC platform floats on the sea surface, using warm surface water to evaporate ammonia, which in turn drives the turbine to generate electricity, while drawing cold deep water to condense the ammonia gas and form a cycle. Singapore is situated near the equator. It enjoys one of the highest surface sea temperatures, creating large temperature differences, which makes OTEC especially effective. It is low carbon as no greenhouse gases are discharged. This generates electricity in an environmentally sustainable way.
Interesting platform. I subsequently visited its renowned vertical farm. Manager of amazing vertical farm, Old Johnny, greeted me. As a small island nation, Singapore is concerned with its food security. The 30 by 30 strategy aims to raise Singapore's food self-production level from 10% to 30% by 2030. To realize this goal, vertical farms are emerging island-wide to best utilize Singapore's limited land space. Yet, this contributes greatly to energy usage. Here in SusTech, the amazing vertical farm is energy efficient and reduces peak hour electricity usage. The rotating stacks allow each row of plants to receive sufficient daylight in limited space, while solar panels installed convert solar energy into electricity, either used for lighting and irrigation or stored in the energy storage system. Energy stored powers the artificial light sources during peak hours at night and rainy days, allowing the vegetables to enjoy optimal growth.
Food produced in the amazing farm is sent to supermarkets and restaurants in the Eco Mall for consumption. Oh, hi, Mr. Grandet. I noticed that the Eco Mall has 2 visually appealing rainbow walls made of heat-resistant material covered by dyed printable solar cells. These solar cells are produced with inkjet printing on sheets of paper-thin, flexible plastic materials. It generates electricity for illumination and other uses in the mall. This suits Singapore's geographical position, as sun radiations have high intensities throughout the year, generating large amounts of electricity. Moreover, the Eco Mall is equipped with a natural ventilation system which removes the need for air conditioning and cuts energy consumption greatly, as air conditioning takes up a generous proportion of an average mall's energy usage in Singapore. Fresh air enters the mall from the windows on the side walls, circulates within the mall through the slits in the central atrium, and exits via the roof, harnessing wind and heat to create a comfortable internal environment with optimal temperature and humidity levels.
Moving on, I set out to visit the factory in the north. Here, excess industrial heat is recollected and reutilized to generate energy. The plant manager, Iron Man, explained the mechanisms to me. Heat produced during industrial processes, such as iron extraction, is collected and converted into electricity by heating up the ethanol stored in the converters, producing ethanol gases which propels the turbine to generate electricity. The electricity generated is then supplied back to the factories to melt hematite. The industrial-related sector remained the largest contributor to electricity usage before COVID, taking up about 41% of Singapore's total consumption. The utilization of excess heat will greatly curb surging industrial demand for commercial electricity and reduce carbon footprint. The time is 5 p.m. now, and the sunset here is really beautiful. What a pleasant journey in SusTech. I've decided to build my new factory here.